Hey everybody, and welcome to what will probably be our last lecture in probability and combinations and things like that. Today we're going to talk about probability and combinations. Computing probabilities where it's to our advantage to use combinations to count the number of outcomes and things like that. Before we actually get to some exercises, let's just review a couple of key concepts. First of all, if E is an event associated with an experiment in which all outcomes are equally likely, then the probability that E occurs is given by the number of outcomes resulting in E over the total number of outcomes. And this is the formula that we use anytime all outcomes are equally likely. Some experiments in which outcomes are equally likely, that we toss a coin, and the two outcomes of heads and tails are equally likely. Another one, we toss a single die, and there are 6 outcomes. We can either get a 1, a 2, a 3, a 4, a 5, or a 6. All of those outcomes are equally likely. No one of those outcomes is more likely than any of the others to occur. And a final example, we have a well-shuffled deck of cards, and we randomly pick one card from inside that deck. All 52 cards in the deck are equally likely to be chosen. So these are examples of experiments where all outcomes are equally likely. And the probability of an event associated with such an experiment, the number of outcomes resulting in that event occurring, divided by the total number of outcomes. Also, there are a couple of other things that might be helpful. The probability that an event E occurs is equal to 1 minus the probability that the event E does not occur. And the probability that the event E does not occur is equal to 1 minus the probability that E does occur. Now let's get on to some applications.